Hello, this is Mr. Huber. In this lesson, we're going to learn about writing algebraic expressions. A key here is to know the words verbally that translate to what mathematical symbols and operations they would go with. So, for instance, when we're looking at addition, okay, we want to know that words like sum, plus, total, more than, increased by, these are all words that would indicate we're adding. So we see a verbal phrase like the sum of a number and 2. We want to indicate sum as addition. So we're going to be adding a number. We can pick whatever we want for that number. We'll do n plus 2. In the next example for subtraction, a number decreased by. So again, we can look at our list here. These are some key terms we should know that indicate that we're going to be subtracting. If you're decreasing something, you're subtracting from it. So a number m decreased by 5, we can write that out as m minus 5. Order matters there, not 5 minus m, but m is being decreased by 5. We're taking the 5 away from the m. And then if we look at multiplication and division, okay, so multiplication, product, times, multiplied by, and of. We're going to see that a little later. That's a key one that might be a little unusual for multiplication, but we'll see it, an example of it, to help clear that up in a little bit. So we have 12 times a number p. When we are multiplying 12 and p in this instance, we can just write them right next to each other. We don't have to have any kind of a multiplication symbol in between them. A number and letter next to each other, coefficient and variable, are multiplying. Division, quotient. Quotient can be one that's a little tricky to remember. Okay, sum, difference, product, quotient are some of the key ones we use for addition, subtraction, multiplication, and division. We also might see divided by, divided into. In this case, the quotient of a number k and 2. So when we have the quotient of k and 2, we can write that as k over 2. You could also write that as k divided by 2. Fractions is a typical way to write some division, so keep that in mind that is division, a numerator divided by denominator. Also look through in these examples here, right? Sometimes a number m, so we're indicating the variable to use, or 12 times a number p, so we're going to use p. In the first one we saw the sum of a number and 2. There was no variable indicated that we should use, so we could pick anything we want. I just picked n, but if you want to use x here or a or whatever your favorite letter is, that's fine. So the sum of a number, what's that number? We don't know. That's where a variable comes in. It represents some quantity that we don't know. Let's look at how we can indicate exponents and grouping symbols, which are part of our order of operations we're going to see in different instances. So there are words that indicate exponents like power and square, and indicating grouping that we're going to see below. So 4 less than the quantity 6 times the number n. So that means we're going to take 4 away from 6n. The quantity 6n and then minus 4. So quantity, that's a key term that indicates we're grouping the 6 and n together. We don't need parentheses for that grouping because 6 times n is already grouped together. In the next one, we're going to need some grouping symbols when we write this out. So when we see 3 times the sum, we want to multiply the whole sum times 3. So we're going to have the sum, 7, and the square of a number y, and we're going to multiply all that by 3. So in that case, we need the grouping symbols to show that we're multiplying this entire sum by 3, not just the 7 or the y squared, but the whole thing is being multiplied by 3. Let's try some examples here, and you should be trying these out and seeing how you do in writing them. So the product of 7 and a number. Product means we're multiplying, so we're going to do 7 times a number. I'll just use x in this case. Again, you could pick whichever letter you want in there because we're not being told a certain variable to use. In the next example, 9 less than twice a number t. In this case, we need to use the letter t. So twice a number means we're multiplying by 2. 9 less than that means we're taking away the 9. Pay particular attention to the order there in that subtraction. The next example is the quotient of 93 and the quantity of y to the 4th power increased by 12. So there's a lot going on there. So let's break this down. Don't try and write it out just going through and putting one thing after another because you have to figure out what might go together, what order. Okay. So the quotient of 93 and the quantity of y to the 4th power increased by 12. So we're taking and dividing 93. So we're going to have 93. And the quantity of y to the 4th power increased, well, not 4th power, not 2nd power, so 4th power increased by 12. So we're taking the quotient and dividing. What's the quotient? 93 and, so 93, and we're dividing it by the quantity. So this whole amount, we're dividing it by the whole amount. You don't necessarily need parentheses here because that fraction bar is grouping the denominator as one quantity. The next example is 1/4 of a number p. This is an example of where of indicates multiplication. 1/4 of something means we're taking 1/4 times p. 1/4 of something is 1/4 times whatever that amount is. So that's where we see of indicating multiplication. Let's look at a few more examples here. These ones are for some situations given to us, maybe a little different in the way they look than those last ones, just given the phrases. So number 5, the number of pages left to read in a 177-page book if you have read p pages. Sometimes in these instances it can be useful to come up with an example and test it. Pick a case. So if you had read, let's say, 10 pages, how many pages do you have left to read? If you read 30 pages, how many pages do you have left to read? Well, however many pages you've read, you take away from the total, and that'd be how many are left over. So in this case, we could use that to help us know that we'd write out 177 minus p. We take the number of pages, subtract how many we've read, and that's how many we would have left over. Okay? And number 6, the amount you're going to spend for B burritos if each burrito costs $8.95. So again, think of an example. If I was going to buy one burrito, it would be $8.95. If I was buying 2 burritos, I'd take $8.95 times 2. If I was going to buy 8 burritos, it'd be $8.95 8 times. So that helps us know then here that we're going to write 8.95 times B. Right? However many burritos times $8.95 for each one will give us the total we're spending for those burritos. One more here, the number of slices for each person if the pizza has 24 slices and there are n people eating it. So we would take, in this case, the total number of slices and divide by the number of people, and that would tell us how much each person is going to get, how many pieces per person. Right? Per indicates a fraction line. Miles per hour, slices per person. We're going to see some of that come up when we're going to talk about rates. But before we talk about rates, let's ponder this and think about Mount Rushmore. What 4 presidents' faces are on famous Mount Rushmore? They're pictured there in the background. No, not me. That's not one of the 4 faces of Mount Rushmore. They are George Washington, Thomas Jefferson, Abraham Lincoln, and Theodore Roosevelt. Those presidents were picked by the sculptor who was selected to carve Mount Rushmore, Gutzon Borglum, and he chose those 4 presidents because he felt they best represented the first 150 years of American history to that point when they were coming through and making this monument, which started in 1927. That's when the drilling began, and it was finished 14 years later, actually by the original sculptor's son. Gutzon actually passed away a few months before it was completed in 1941. And the sculpture was completed 90% by blasts of dynamite. So that's a lot of dynamite there used to blast it. And if you see it in person, I encourage you to check it out. It's really pretty cool. That's a few years ago. I was there visiting, and it's really quite something to see in person, the size and scope, and just imagine them carving it that lifelike with a dynamite at a cost of just under $1 million back in the day. All right, now let's go back to some math here and talk about rates and unit rates. Okay, a rate is a fraction that compares 2 quantities measured in different units. So I just mentioned before, like miles per hour, right? That's different units, miles and hours. So a rate is that type of a fraction, comparing 2 quantities in different units. A unit rate is when you compare the denominator and it's as 1 unit. Okay, when the denominator is 1 unit, like how many miles per 1 hour, that's called a unit rate. And unit rates are particularly useful for different situations. We're going to see some of those here coming up. Let's look at number 8. So if we want to find the cost per ounce of something, maybe there's at the store 2 different sizes, and we know which one's the better buy. Right? Well, the prices might be different, but we want to figure out the cost per ounce, per liter, per whatever it might be that we're buying, so we know which one actually makes more sense, which is the better buy. So here we have a 20-ounce bag of chips that cost $4.80. We wanted the unit cost per ounce. So again, that word per, that indicates our fraction. Cost per ounce. So we're going to put cost over ounces. All right, so in this case, we have $4.80 over 20 ounces. And we want to get that to be 1 ounce. So we're going to divide $4.80 divided by 20. If we do that, we're going to find that we get 0.2. Let's write out the division here because I know sometimes long division can be tricky. So we have 4.80. Right? So 20 goes into 48 two times. That's 40. And then we'd subtract, and we have 80. 20 goes into 80 4 times. And our decimal point right there, so 0.24. So 24 cents per 1 ounce. So each ounce costs 24 cents. That might help us look and we see another bag that's maybe 35 ounces. We figure out how much does that cost per ounce. Maybe that's 20 cents per ounce. Okay, that's cheaper per ounce if we want to compare and see what's a better buy. Sometimes that's a useful situation where we want a unit rate. We want to compare it to the same 1 unit in the denominator. All right, so that's an example of a unit rate. We're going to see another example of a unit rate here. And speed is often used as a way for unit rates to come into play here. A car travels 120 miles in 2 hours. Find the unit rate in miles per hour. So again, miles per hour. 120 miles per 2 hours, right? That fraction line. So that would come out to 60 miles per hour. 60 miles per hour, that would be our unit rate. And now we want to find this rate in feet per second. So we have to do some unit conversions, unit analysis. Okay? So if we have 60 miles per 1 hour, right? We want to convert that to feet per second. So you can convert the miles to feet or the hours to seconds first, and then the other one, it doesn't matter. I'm going to do the miles to feet. So when we do this, we want the miles to cancel out. And we're going to have feet here. That helps us know which one goes in the numerator and denominator. Pay attention to the units. Right? We want the miles to cancel, so we'll have feet in our final answer. And it tells us here there's 5,280 feet per 1 mile. So now we've got the feet, but we want feet per second, and we've got hours. So we need to turn hours into seconds. So first we want to turn hours to minutes. Why did I write the hours in the numerator? Well, here I have hours in the denominator I need to cancel out, so I'm going to need an hours in the numerator to cancel out with it. Denominator and numerator will cancel each other out. So I'm going to have hours and hours canceling each other out. And 1 hour is 60 minutes. Next, I want to get that to feet per second still, right? It's feet, so I've got the feet part per second, so I need to have seconds. So now I need to convert the minutes that I have to seconds. So minutes and seconds. So 1 minute is 60 seconds. And we can see here the minutes and minutes cancel. And our final answer is going to be in feet per second. So now I need to do the calculations. And when I do this, to make things a little easier, I can do 60 and 60 canceling each other out. So I'm going to have 5,280 feet per 60 seconds. Right? When I multiply fractions, I multiply across the numerators, I multiply across the denominators, and now if I want to get a unit rate, I'm going to want to calculate what that would be per 1 second. So I'm going to do 5,280 and divide it by 60. That will come out to 88. Okay, so this will come out to 88 feet per second. And again, we want to look at the units. Pay attention to the units here and make sure they're working out. When I go through, I have feet in the numerator, per seconds in the denominator. That's why I wanted feet per second. So use the units to help you know where the numbers should go. Place the units first, and then the numbers that go with those will follow in the right spots so you can multiply and divide as you need to get your final answer. So as we go back to translating verbal expressions to algebraic, know those key terms that indicate the different operations and how to write those out, and so how we apply that to different real-world situations. There are definitely going to be applications of what we're working on, and rates and unit rates are another example of that as well.